Hello everyone, the Snitter here, and today I'd like to show you how you can make your own path system in GameMaker Studio 2. GameMaker has a path resource that lets you place path points and select whether or not the path is smooth or closed. However, it has a huge limitation if you plan to use it for 3D games. It only works in 2 dimensions. So in this video, I will explain how we can create a path system that works pretty much like the built-in system for any number of dimensions. Let's start by analyzing a built-in path. Notice how when I turn on smooth, the path does not entirely reach the path point anymore, but then crosses the line between the path points at the middle. Recreating this will be a perfect start for our new path system. So let's start by creating a new object in a new room and place the object in the room. I read all the path points from the path so that I can interpolate between them manually. Let's draw some lines between them. To begin with, I'd like to only consider the first 3 points in the path. Then I want to create a variable that scrolls from 0 to 1 and then jumps back to 0. This can be done by putting the current time inside the fraction function. I will utilize this to linearly interpolate between the first 2 points using the lerp function. Then I will do the same to the line between the next 2 points. Now I have 2 scrolling points. The next thing I want to do is to draw a line between those 2 points. Then let's try doing a linear interpolation across that line as well. Okay, so now that middle point is actually moving in a smooth curve between the control points. Removing all the extra lines makes it a little easier to see. Now let's draw the entire path all at once using a loop. Let's add that last path point as well and figure out how we can continue the path all the way through. Right now we have no obvious way for continuing this path, so we need to change things a bit. Remember how the path in GameMaker crossed the middle of the line between the 2 path points? We need to also do that with our new custom path. So now the path ends at the middle of the line between the 2 control points. Let's try continuing the path by drawing the next segment as well. And there we have a smooth continuous path between 4 control points. We don't have the ends just yet, but let's worry about that later. First, let's organize things a bit better. I want to create a new path resource as a constructor function. This will contain info about the path, like whether it's smooth or closed, and it will also contain a list of all the control points in the path. I also gave it a custom static function for adding new path points. Now each path point will actually be a separate struct so that you can easily store custom info in them. This struct is also returned from the addPoint function. Now, the entirety of the path length in GameMaker is mapped to the range from 0 to 1. In order to do this, we'll need to first find the total length of the path. For the time being, I will just find the distance between the control points by looping through them and using point distance 3D. Let's assemble a function for getting a world space position from the path at a given normalized path position. Remember, the normalized path position goes from 0 to 1, with 0 being the start of the path and 1 being the end. So in order to figure out which segment we need to sample, we can loop through the path from the beginning and add up the distances until we find the correct segment. Now that we have found the correct segment, I'll copy over the code for doing quadratic interpolation that I created earlier. I'll remap the path position to the variable t so that it stores a value of 0 at the start of the curve and 1 at the end. Let's also put together a function for drawing the path. This time I will iterate through the path at small intervals and draw a line from the previously sampled point to the next. Now let's put all of these new functions to the test by using them in the object. I'll create a new path struct by using the constructor function, and I'll add all the points to that path. I'll leave z at 0 for now, and just know that it still works in 3D even though it looks 2D. So there we have our continuous, smooth, closed path. Let's draw a point that follows the path all the way through. Okay, so there's our moving point. It's beautiful. Wait. It looks like it doesn't move smoothly. It seems to speed up and slow down at different points in the path. Let's see what happens if we add more path points to the path. As you can see, the quadratic interpolation is messing up the speed of the point. We'll need to do some pre-processing to make it smoother. Instead of storing the path as a set of control points, I'll store it as a set of segments. Each segment will be a separate struct with its own set of functions. The segment will reference 3 points, stored as A, B, and C. I'll move the quadratic interpolation into the segment struct's static functions. Next, I'll need to find the curve length of the segment. I also create an array for mapping the path position along the curve to the actual distance travelled, so that we can smoothen the movement speed along the path. I divide the curve map values by the curve length so that they store a value between 0 and 1. The segment will also store its own position along both the curved and the straight path. Let's do some refactoring here. I'd like for the points to be arguments to the constructor function instead of being read from the control point list. I want the segment array to start out as uninitialized so that the path is automatically updated when you try to read from the path. In the update function for the path, I loop through all the segments to update their lengths. Then I loop through them again and divide their positions by the total path lengths so that they are normalized to the range 0 to 1. Next, I make the getPosition function return -1 if t is less than 0 and 1 if t is larger than 1. This will be used for more quickly searching for the correct segment later. I create a new function for getting the smoothened path position. This will search through the curve map and find the best fitting part of the segment. The variable I would have been correct if the distances in the curve had been uniform. They are of course not uniform, but this makes for a nice starting point for our search. We want to find the value of I where p1 is less than t and p2 is larger than t. Then we can remap t from the non-uniform range to a semi-uniform range like this. Let's also make use of these new functions in the path struct. To speed up searching for the correct segment, I will make use of the returned values from the segment's getPosition function. Now it's time to test this again, and... well, I messed up somewhere. Let me just quickly fix some bugs. Oh, okay, it looks like it didn't actually work in 3D after all, but adding that third dimension is pretty easy. Now our point is moving along the path at a constant speed, and the path system is getting close to completion. Let's focus on the function where we do quadratic interpolation. Using lerp makes it easier to understand what's going on, but it's not a very optimized way of doing things. Luckily, lerp is a very simple function to write out as a mathematical formula. This part might be a little hard to follow, but I'm basically writing out the entire equation so that I can simplify it as much as possible. My goal is to end up with a weight value for each of the segment's 3 control points. I'm speeding through this as watching me move terms around can be a bit tedious. So now the function finds a weight value for each point. These weight values are very useful as they can be used to interpolate between other things as well. Say for example you want your path to store camera orientation for making flying cameras. Then you can use the weight values to interpolate between orientations, so you need to return them from the function. However, right now the function is creating a new array every time it is called. This will bog down the garbage collector after a while, so let's create a static array and return that instead. Let's enable open-ended paths. This can be done in the paths update function by changing what points are referenced in the segments. I want to simplify things a bit. We no longer need the get plus raw function as that returns a wrong value anyway. I can also move some variables around and make the whole thing look a bit neater. In order to add support for straight paths, I'll rename the segment to curve and add a new segment type called line. In the update function of the path, I'll do a check to see if the path is smooth or straight, and add curves or lines respectively. Now the path system works with both open and closed paths that can be either smooth or straight. As a final touch, I'll add functions for changing these settings. Whenever you change the settings, it will also reset the segments array so that the path automatically gets updated again. And that is all the functionality we need to extend the built-in path system to 3D. I've cleaned up the code and put together a little demo project with a minecart following a track, which you can download from the link in the description. And that was it for this video. Thank you for watching. Feedback is always appreciated. I'll see you in the next video.